Now we will discuss the next property of the transition element, that is catalytic property. All of you know the transition elements are colored. Their n-1d orbitals are incompletely filled, or n-1d orbitals in which electrons are unpaired, and most of the n-1d orbital are vacant, as well as they possesses variable oxidation state. As they possesses variable oxidation state, therefore used as a catalyst. They having a role in the reaction as a catalyst, and that means they have a good catalytic property. It is because of vacant d orbital or unpaired electrons present in the n-1d orbital. Therefore, they provide the larger surface area during chemical reactions to the reactants and to convert it into product. The substance which provides larger surface area, the substance, the element, the compound which having variable oxidation state, those compounds act as a catalyst. Therefore, transition element in which most of the n-1d orbitals are vacant or having unpaired electron, therefore they provides larger surface area for the reactants, therefore they have the catalytic property. They forms homogeneous catalysis, reaction. That means they participate in homogeneous catalysis reaction as well as heterogeneous catalysis reaction. That means all of you aware of that homogeneous catalysis. Homo means same. That is when catalyst and reactants are present in same phase. That means if reactants are gaseous and catalysts are in gaseous state, then it is a homogeneous catalysis process. Both are, that is catalyst and reactants are in solid state, then that type of reactions are called as homogeneous catalysis process. And what is heterogeneous? See here, hetero means different. That is, it is a chemical reaction, it is a catalysis process in which reactants and catalyst are in different state. If catalyst is in solid state and reactants are in liquid or gaseous state, then it is a heterogeneous catalysis reaction. These type of reactions already you have studied in the 11th standard, isn't it? Then transition elements having capability to participate in the different oxidation and reduction steps of catalytic reactions. They have ability to participate in the steps of the catalytic reactions, and they itself undergoes oxidation or reduction by changing, by showing, by exhibiting variable oxidation state. Therefore, oxidation state of the metal ion changes and the catalysis reactions are occurred. For example, the elements from transition series, from all transition series, there are 4 transition series. The elements, that is iron, cobalt, nickel, copper, zinc, platinum, chromium, palladium, etc. act as a catalyst. All of you aware of that. This type of elements, these all elements used as a catalyst in different type of reactions, and these catalysts are used to enhance the rate of the reactions, or few of them act as a promoters. All of you aware of that in Haber process, that is ammonia formation from M2 and H2, there are promoters as well as catalyst, and these promoters and catalyst are from transition elements. Then in homogeneous catalysis reaction, the metal ion participate by forming unstable intermediate. All of you know that intermediate compound means the compound, the complex compound which is formed due to the reaction between reactant and catalyst. As the reactant and catalyst are in same phase, in same state, in homogeneous reaction, then they form the unstable complexes, which is called as intermediate compounds or intermediate complexes. Then suddenly these intermediate compounds are converted into products. In homogeneous catalysts, metal ions participate by forming unstable intermediate compounds, and in heterogeneous catalysis reaction, metal ions provide the larger surface area to the reactant molecules to form the bonding, and they are converted into products. Then we will see few more examples of catalytic reactions or catalysis reactions. First, the example of catalysis or example of catalytic reaction in which transition elements or their compounds used as a catalyst, that is KClO3. KClO3, that is potassium chlorate, which undergoes decomposition on heating, and in this process oxygen is liberated by decomposition of KClO3, that is oxygen is liberated and oxygen production takes place and decomposition of KClO3 takes place. Here this process is used for the production of oxygen. In this process, if catalyst is not used, then production of oxygen is very less. In this reaction, if MnO2, that is manganese dioxide, which is black color powder form, pulverized form, that MnO2 powder is used as a catalyst, then the rate of this reaction enhances or increases and larger production of oxygen takes place. Therefore, here MnO2 acts as a catalyst. Then one more example, that is Haber process. Haber process is related with the production of ammonia. Ammonia formation or ammonia production takes place by Haber process, and ammonia formation takes place from nitrogen gas when reacts with hydrogen gas. Then at 773 Kelvin, formation of ammonia takes place, and here iron or molybdenum used as a catalyst. And when these catalysts used in this process, more and more production of ammonia takes place and reversible reaction is restricted. If this type of catalyst is not used, then this process may becomes reversible and production of ammonia, it may be smaller or it may be less. Therefore, iron and molybdenum is a good catalyst in the production of ammonia during Haber process. Then one more example, all of you aware of that, hydrogenation of alkenes, which is an unsaturated hydrocarbons which undergoes hydrogenation, means reduction. Here ranne-nickel if used, ranne-nickel which is used in this process, then that unsaturated hydrocarbon is converted into saturated hydrocarbon, that is alkanes. Here ethene, when undergoes reduction in presence of ranne-nickel on heating, it gives ethane. That means here nickel is used as a catalyst, and which is a nickel is a transition element. Ranne-nickel means it is a finely divided powder which is obtained during the hydrogenation or hydrogenation of the oxides of elements. When heated, then ranne-nickel is obtained, and this ranne-nickel is used for the hydrogenation or reduction of alkenes into alkanes. That is, commercially oils are unsaturated in nature and at room temperature it is liquid in nature. Therefore, oils when undergoes hydrogenation, that means reduction in presence of rank-nickel. Then they converted it into solid fats, that is saturated compounds, and that solid fat is called as vanaspati ghee, or it is used for the production of vanaspati ghee as well as the production of margarine. Margarine, all of you studied about that. Margarine is used in the vegetable cake, that is eggless cake. For the fermentation, margarine is used, which is a solid fat, and for that production rank-nickel is used as a catalyst during conversion of edible oil into solid fats or vegetable ghee. Then one more example is there, that is contact process. All of you aware of that. Contact process is the production of sulfuric acid. Then in the production of sulfuric acid, that is contact process, during production of sulfuric acid, in previous stage SO2, that is sulfur dioxide, undergoes oxidation. Oxidation, that is oxygen from air when reacts with sulfur dioxide, it get converted into SO3, that is sulfur trioxide, which is in also gaseous state. And during this oxidation process, here Fe2O5 or here asbestos, platinized asbestos sheet is used as a catalyst for conversion of sulfur dioxide or oxidation of sulfur dioxide into sulfur trioxide, and that sulfur trioxide again used for the production of, in the manufacturing of sulfuric acid, and that is the contact process. Here vanadium pentoxide or here platinized asbestos sheet during production of carbon dioxide and hydrogen from carbon monoxide, which is in gaseous state. When carbon monoxide, it is heated with steam, which is converted it into CO2 and H2. Here in this process catalyst is used, that is iron and chromium, alloy of iron and chromium at about 500 degree Celsius. Then alloy of iron and chromium is used in the production of CO2 and H2 from carbon monoxide. Alloy of cobalt and alloy means it is a mixture of different types of metals or metals and non-metals. Then alloys of transition elements are also act as a good catalyst. Therefore alloy of cobalt and thorium, it is used in the Fischer-Tropsch process. Fischer-Tropsch process, and that is the process which is useful for production of gasoline. That is about the catalytic property of transition elements. We are going to study about the two more properties of the transition element, that is formation of interstitial compounds. Interstitial compounds, and second one, that is alloy formation. First of all, we will discuss about the formation of interstitial compounds. Then what is interstitial compound? Interstitial compound, the name itself indicates, it is a compound of transition elements which is formed by adding, or it is formed when small elements which having small atomic number, less atomic number, these are get trapped or captured into the interstitial space of transition elements. All of you studied about the metallic characteristics, metallic structure, that is lattice structure of transition elements. Most of the transition elements which having HCP or CCP lattice structure or BCC lattice structure. All of you studied about that in solid state. Then transition elements having typical metallic character and they having typical metallic lattice structure. Therefore, in their interstitial space means if the metal ions which is present in the lattice structure which having a different type of lattice structures, that is HCP, CCP or BCC, then in its interstitial space, here that is the interstitial space of metallic lattice structure, in this interstitial space, small element, atoms of small element like hydrogen is get trapped when added into it, then it get trapped into the interstitial space of metal lattice structure. Then the compound which is obtained is called as interstitial compounds. Then metallic or transition elements which having ability to form a large amount of interstitial compounds. It can forms the hydride compounds, sulfide compounds, carbide compounds or oxide compounds. When hydrogen get trapped into the lattice structure of metal, then the interstitial compound which is formed is a hydride. Similarly, oxygen element when trapped into the metal lattice, then the interstitial compound is oxide, or nitrogen when trapped into lattice structure, then it is a nitrides of that element, and sulfides of sulfur. That all are different types of interstitial compounds. And when these compounds are formed, or original properties of transition elements changes. For example, iron is soft and it is reddish in color, but when carbon is added into it, then the interstitial compound which is formed by adding carbon into the iron, then iron becomes more hard. That means when interstitial compounds are formed, then these transition metals loses their malleability and ductility. That means malleability and ductility decreases and these type of compounds becomes more harder. And then we will discussing about the properties of interstitial compounds. What are the main properties of interstitial compounds? Interstitial compounds. Then see here, first property of interstitial compound, that is they are hard, because when small elements like hydrogen or carbon when trapped into the interstitial space, then carbon gives hardness to that element. For example, stainless steel. Stainless steel is it is an interstitial compound of carbon and iron. Then steel is more harder than the iron. Iron is soft and reddish in color, but steel is grey or silver color and becomes harder than the iron. Then and melting point of those elements increases. That means interstitial compounds are harder than the original metal transition elements. It having a high melting point. The few properties changes of the original metals during formation of interstitial compound. The interstitial compounds are also good conductor of electricity and heat. That means this property of metal does not changes, it remains as it is. Then chemical properties of the interstitial compounds are similar to those of original metal lattice. Then melting point and hardness increases of the interstitial compound than the pure metal from which it is obtained. Densities of these interstitial compound is less than the original pure metal, because when these elements like sulfur, nitrogen, oxygen or hydrogen get trapped into the interstitial space, then these metal ions get goes apart from each other, and density of interstitial compound decreases. Then one more thing I am going to discussing here, that is, if the carbides of this type of metals are formed are called as metal carbides. These metal carbides are chemically inert and which is extremely hard, which is like a diamond. Then instead of diamond we can use these type of carbides. When there is difficulty to use the diamonds because of its price, then we can use carbides of metals during the cutting of glass or during the drilling of rocks, because it has same property, that is same hardness like the diamond, as well as they are chemically inert. And hydrides of transition metals, hydrides means when hydrogen get trapped into the metal lattice of transition element, then these are the hydride interstitial compounds which is used as a source of hydrogen, and that is the good reducing agent which is used in the reduction process or different chemical reactions. Hydrides of the transition metal is used as a catalyst, or it is used as a good reducing agent. That is about the properties of the interstitial compounds. Now we will discussing on the last property in this chapter of transition element, that is alloy formation. All of you aware of that alloy. What is alloy? Alloy is a homogeneous mixture of metals and metals, or metals with non-metals are called as alloy. You knows about the different types of alloys. There are stainless steel, bronze or brass. These are the alloys which is used in the common daily life. Then we will discuss the alloy formation property of the transition element here. Then the transition element consists of iron, nickel, cobalt, gold, silver, platinum, etc. And these type of transition metals having capacity to form the alloys. Then alloy formation takes place when the elements, atoms of the elements of one of the metal get distributed in the atoms of another element in the lattice structure of another element randomly, then and forms the homogeneous mixture of two or more type of different metals, or two or more different types of metal and non-metals are called as alloys. Then alloys of transition metals are of two types, that is ferrous alloys and non-ferrous alloys. There are two types of alloys of transition metals we have to discuss here, that is ferrous alloys and non-ferrous alloys. See here, ferrous alloys. The name itself indicates ferrous means iron. It is an alloy of ferrous. It is an alloy of iron. And when other elements are get randomly distributed in the lattice structure of iron, then that alloy which is formed is called as ferrous alloy. Therefore, here in this type of alloy, the main element is iron. Therefore, these alloys is called as ferrous alloys. All of you knows the different types of ferrous alloys, that is stainless steel. Stainless steel is the most popular alloy, that is ferrous type of alloy. Then stainless steel, it is a alloy of iron. The main metal which is present in it is iron, cobalt, nickel, sometimes chromium is used, and carbon, which is used to make it hard and tough. All of you aware of the different types of steels. There are nickel steel, chromium steel, stainless steel are the different types of steels, which is a type of ferrous alloys, which having the 2% of carbon, which gives the toughness to that alloy. That means here tenacity, that is toughness, strength of that alloy increases due to the formation of that type of alloy. And these are used in different processes or different places wherever it is necessary, and the uses of these type of alloys is different. Then non-ferrous alloys means these are the alloys which is formed from transition element other than the iron, except iron. That means other transition elements except iron forms the alloys with another type of elements. Then that alloys are called as non-ferrous alloys. For example, all of you know the brass. Brass is an alloy of copper. Copper is a transition element, and zinc. Zinc is also transition element, but iron is not used in the brass. That means brass is an alloy of copper and zinc. Then uses of brass, all of you aware of that. It is used in the utensils, and it is also used in the coins and statues, etc. Then one more non-ferrous alloy, that is all of you know that is bronze. Bronze is a alloy of copper and tin, Sn, that is tin, which is used in the metal. Then we will discussing about the uses of these type of ferrous alloys as well as non-ferrous alloys. Bronze, which is the alloy of copper and tin. The properties of original transition metal changes. That means here bronze becomes tough, strong and corrosion resistance, but copper is a soft and which having the corrosive property, or it undergoes corrosion, and therefore as the property of these transition metal enhances during the formation of alloy, then these alloys are used. That bronze is used in the statues, medals and trophies. Then one more alloy, that is cupra-nickel alloy. The name itself indicates it is the alloy of copper and nickel. Then this type of alloy, that is cupra-nickel alloy, is used in the machinery part of marine ships, and it is used in the marine condenser tube in the boats or marine ships. Then stainless steel. Stainless steel is used as a outer fuselage of the in ultra high speed aircrafts. Nichrome is one more alloy, which is the alloy of nickel and chromium, having the ratio of nickel and chromium is 80 to 20. That means 80% nickel is there and 20% chromium is there, which is used in the gas turbine engines. Then titanium alloy, which is the alloy of titanium, which is having the property temperature resistance. That means it high temperature, it cannot be get melted. That means the melting point of this alloy is greater. Therefore, it is used in the ultra high speed flights. It is used in the fireproof bulkheads, as well as it is used in the exhaust shrouds. That is about the alloy formation or properties of alloy and uses of alloys of transition elements. We studied different types of properties in detail of the transition elements. Thank you.